Hello everyone, I'm Amulya BR of Sri Venkateshwara College of Engineering and I belong to the branch CSC AI. So today I'm back with another video on the subject data science and its application. And today's topic is on a multiple topic, so this is an assignment. So now let us look into the contents. The contents are Introduction to Continuous Distribution, Normal Distribution, Properties of Normal Distribution, Standardizing the Normal Distribution or the Normal Random Variables, the Central Limit Theorem, Sampling Distributions, Hypothesis Testing and P-values, Confidence Intervals, Applications of Normal Distribution in Data Science, and Conclusion and Key Takeaways. So now let us see the introduction to continuous distributions. So continuous distribution describes the probability of continuous random variable that can take infinite number of values in a given range. So unlike discrete variables which have distinct and separate values, for example like roll of a die, examples include measurement like height, weight, temperature, and time. So these are examples of continuous distributions. So the key properties of continuous distribution is that it has a probability density function. So the PDF of continuous random variable will describe the likelihood of variable taking a specific value. The area under the curve will give an interval the probability that the variable falls within that interval. For example, in normal distribution, the probability distribution function is the familiar bell-shaped curve. So, and then another property is that it has cumulative distribution function, that is CDF. So this CDF will represent the probability that random variable will take a value less than or equal to the given point. It is monotonically increasing function that is ranging from 0 to 1. And then another property is mean and variance. The mean will provide a measure of central tendency of distribution. So the variance will measure the spread of the values around the mean. So these are some of the properties of continuous distribution. Next up, we have normal distribution. So, normal distribution is a continuous probability distribution. It is categorized by symmetric and bell-shaped curve. So, this distribution is defined by two parameters. So, one is mean, the other is standard deviation. So, mean is the central value around which the data points are distributed. So, then standard deviation. Standard deviation is a measure of spread of the data points around the mean. And then let us see the properties of normal distribution. So the first property is symmetry. The normal distribution is symmetric about the mean, which means that left and right side of the curves are mirror images of each other. And the next characteristic is the bell-shaped curve. This distribution will form a bell-shaped curve with highest point at mean. And then the next property is it has mean, median and mode. In normal distribution, mean, median and mode are all equal and they are located at the center of the distribution. So these are some of the characteristics of the normal distribution. So again, as we discussed in the previous slide, the properties of normal distribution. So it is nothing but the bell-shaped curve, symmetry. So again, we have here the bell-shaped curve is divided into like two approaches. So one is unimodal approach. So this distribution has single peak which occurs at the mean, which indicates that the most values will cluster around the central point. So and then we have another approach, that is tails approach. So this approach is it indefinitely or infinitely extends in both directions approaching, but it never touches the horizontal axis. So and then we saw the parameters like mean, standard deviation. So and also it has the empirical value. So this empirical value, it states that any normal distribution, the percentage of data falling within 1, 2 and 3, the standard deviations are 68%, 95% and 99.7 respectively. So These are the properties of normal distribution. Now we'll see how to standardize the normal random variables. So standardizing the normal random variables is a crucial technique in statistics which will allow for comparison of data from different normal distribution, and it will simplify the calculation. So this process will involve transforming. So transformation is a step. So it transforms a normal random variable into standard normal variable, which means which has a mean of 0 and standard deviation of 1. So here another step is the identification of mean and standard deviation. Determine the mean and standard deviation of normal distribution happens in this step. So this standardizing will apply the z-score formula. So this z-score formula is calculated using a formula, and then we have applications. So applications of standardizing normal variables is that it can be easy for comparing scores. So standardizing will allow for comparison of scores from different normal distributions. For example, we can compare the test score from different exams with different means and deviations. And then the probability calculations is another application which enables us to use the standard normal tables to find the probabilities and percentiles. So next we have the central limit theorem. So we'll see the statement of this. So the central limit theorem states that given a sufficiently large sample size, the distribution of sum of independent and identically distributed random variables will approach a normal distribution regardless of original distribution of variables. So we'll see the statistical inference of this statement. So this justifies the use of normal distribution in making inference about population parameters. Like for example, it underlines the rationale for using normal distribution to construct confidence intervals and to conduct the hypothesis test. And then we can simplify this central limit theorem as even if population distribution is unknown, the distribution of normal sample mean can be approximated as normal. And some of the real world applications is that it can be used in various fields such as engineering, economics, and natural science. For example, it is used in quality control process and decision making under any uncertainty. Moving on to the next slide, we have the sampling distribution. So what is sampling distribution? There's a fundamental concept in statistics that will refer to the distribution of statistics calculated from multiple samples taken from same population. So understanding the properties of sampling distribution is very much crucial for making inference about the population parameters. So some of the practical applications are the confidence interval. Sampling distributions are used to construct confidence intervals. And then is the hypothesis testing. In hypothesis testing, the sampling distribution will help to determine the probability of obtaining sample statistics. And then it is used in quality control for assessing the variability of measurements and to make decisions about any process. Next, we have hypothesis testing and the p-values. So, hypothesis testing is a statistical method of making decisions or drawing any conclusions about population based on any sample data. It involves formulating null hypothesis and alternative hypothesis, so which is used to collect data and use any technique to determine whether there is enough evidence to reject the null hypothesis in favor of alternate hypothesis. So p-value next is, so the p-value is a crucial concept in hypothesis testing. It provides a measure for strength of evidence against the null hypothesis. So null hypothesis, we'll see what is null hypothesis. So it is the default assumption that there is no significant difference or effect. And then we'll see what is alternate hypothesis. So it is the claim or assertion that contradicts the null hypothesis. So this represents the researcher's belief that there is significant difference or effect. So this is the alternate, the opposite of null hypothesis. Let us move on to the confidence intervals. So confidence intervals are basically a tool which is used to estimate the range within which population parameters like mean or proportion is likely to be present there. So they provide a range of values for parameter based on a sample data. So it will also provide the level of confidence regarding the accuracy of the interval. So the components of confidence interval is, so it is represented as point estimate plus or minus the margin of error point estimate plus or minus the margin error. So the components are point estimate. So the sample statistic, that is, it serves as the best estimate of population parameter. So the next component is margin of error. The range of values added and subtracted from point estimate to create the interval is margin of error. So this confidence interval will provide a range of values where we believe the true population is likely to reside based on the sample data and the confidence level. Now let us see some of the applications of normal distribution in data science. So the first application is statistical modeling and analysis. So the normal distribution is often used to describe and summarize the data. So parameters such as mean and standard deviation will provide insights into the central tendency. So the next is hypothesis testing. Many statistical tests will assume that data follows normal distribution. So for this, we need to conduct the hypothesis testing. So the next one application we have as machine learning and predictive modeling. So for this, it requires regression analysis and classification models. So in regression analysis, techniques like linear regression, it follows normal distribution. This assumption is crucial for model coefficients and classification models. Statistics also use the theoretical distributions, often using the normal distribution as a reference for it. So these are some of the applications of normal distribution in data science. So now we have come to the conclusion. Normal distribution is categorized by its bell-shaped curve, as we saw earlier, and it is central to the statistics, and it is used in many models for predictive the natural phenomena, and it is also used in hypothesis testing. So hypothesis testing is a methodological approach to claim about population using sample data. So we saw about the confidence interval where it provides range of values for population parameters. So they are constructed using the sample statistics. So then we saw the applications where they are used for statistical modeling or hypothesis testing, quality control, and financial analysis. So overall, the understanding the normal distribution and confidence intervals is crucial for conducting the statistical analysis and to make the informed decisions or to draw any conclusions from the data of sample. So that is it. I thank each and everyone for watching the video completely till the end. I also request you all to please like the video and share the video amongst your friends. I also will make sure to come back with another video on a different subject and on a different topic. Until then, have a good time. Thank you.